Hi, my name is Trent Roberts. I'm a soil fertility extension specialist with the University of Arkansas System Division of Agriculture. And what I want to do today is take about 15 or 20 minutes and discuss some of the questions that I've been getting here lately related to nitrogen applications and some of the untimely weather events that we've been getting. What I hope to do is kind of address some of those questions and give you an idea of potentially estimating nitrogen losses that you may have from some of these scenarios. So what I've done is put together a brief PowerPoint presentation to try and help facilitate discussing and answering some of these questions. So on here, I have my email address. At the end, I will share my cell phone number. That way, if any of you have questions, feel free to reach out to me and we can try to address your concerns as best we can. So just for a general title, I wanted to call this Nitrogen Dynamics and Estimating Nitrogen Loss. As far as a topical outline, I want to talk about how complex the nitrogen cycle is, specifically in our row crop production systems here in Arkansas. I'm going to cover ammonia volatilization, which is a net loss from our soil system. I want to talk about nitrification, which is simply a nitrogen transformation. It does not result in a net gain or a net loss from the soil. We're going to talk about denitrification, which is another loss mechanism from the soil. And at the end, we're going to go through a couple of examples where we try to estimate potential nitrogen losses from our row crop production fields. So really the million-dollar question. This is the one I've been getting quite a bit over the last few weeks with the weather patterns and the timing of the growth stage for our corn, rice, and a lot of our row crops in the Delta. And the question is, I applied X units of nitrogen a certain number of days ago. And really what they want to know is specifically for rice, how much of that can I potentially count towards my pre-flood nitrogen rate? And what I'll try to do today is go through and show you how complex this particular, answer is, but also try to talk to you a little bit about ways that we can estimate it and let's get in the ballpark. So first off, if we just look at the nitrogen cycle specifically for a rice production system, the one thing that you'll notice it is very complex, but we have things that we can simplify down into net additions, net losses, and then just transformations within the soil. And there are three in particular that I'm going to talk about today. The first one that I want to cover, is a nitrogen loss mechanism, and we refer to it as ammonia volatilization. So this is a surface loss mechanism, and it's essentially where we have ammonium that gets converted to ammonia, which is a gas. Since this is a recorded presentation, I've added several notes with much more detail down at the bottom. So feel free to pause this recording and read those notes a little bit more in depth. One scenario where we really have to worry about ammonia volatilization loss is when we use urea or urea-based fertilizers. And part of the reason for that is when we look at urea, by nature, it is an organic nitrogen compound. And most plants cannot take up urea. It has to be converted or hydrolyzed into ammonium before it can be taken up by our row crop plants. And so if we think about this, the conversion from our organic nitrogen of urea to ammonium is a process called hydrolysis. And it is catalyzed by the urease enzyme. Excuse me. And so as we go through this process, we're going to convert it into a plant available nitrogen form, ammonium. And then if our soil or environmental conditions are favorable, we can have that converted to ammonia gas, which is essentially lost from the soil into the atmosphere. Or if conditions are favorable, we can have that ammonium attracted to the cation exchange sites in our soil. And so there are a lot of environmental conditions that can play a role in this particular loss mechanism. But one thing to remember and that I really want to emphasize is that it is a surface loss mechanism. And so if we can incorporate this urea via tillage, irrigation, or rainfall, then we eliminate ammonia volatilization as a loss potential for that nitrogen. And so one thing that we try to do is we actually use urease inhibitors. Our most common one is NBPT. And what we're trying to do is block this urease enzyme and prevent the conversion from urea to ammonium until we can get that fertilizer incorporated. And once again, that can be with tillage, irrigation, or rainfall. But essentially, if we can block this hydrolysis or block the function of this urease enzyme and incorporate that urea into the soil or below the soil surface, then we've effectively eliminated that volatilization loss potential. The next thing that I want to talk about is nitrification. And so once again, this is just a transformation in the soil. It doesn't result in a gain or a loss. And all it is the conversion from ammonium, which is a positively charged cation and is typically attracted to our soil cation exchange sites, to another form of plant available nitrogen known as nitrate, which is a negatively charged anion and is not attracted to our soil cation exchange sites. Now, one important thing about this conversion is that even though it doesn't result in a net loss of nitrogen from the soil, nitrate, that particular form of nitrogen, is much more prone to loss than ammonium. And so in a lot of cases, specifically in rice production, if you think about ammonium in the soil, our really only major loss pathway is going to be plant uptake. And so if we can keep it in this ammonium form, well, in a lot of ways that nitrogen is safer, or it's less likely to be lost from our soil system. But as soon as we convert or transform this nitrogen from ammonium to nitrate, then we significantly increase the loss pathways and the loss potential. And if you think about nitrate, it can be lost via leaching or denitrification. In our production systems, especially where we grow rice, leaching is not much of a concern just because, net downward movement of water is restricted, due to hard pans, restrictive layers, or just the soil textures that we use for rice production. So leaching isn't necessarily a concern in most of our soils, but denitrification can be a major concern. Now, if we just think about this conversion from ammonium to nitrate, the one thing that I want you to remember is that you must have oxygen present in the soil for this to occur. And so the soil needs to be in an aerobic state, which means it can't be saturated and it can't be flooded. Now, ideally, nitrification is going to occur at about 60 to 70% water-filled pore space. So there still is oxygen present in the soil, but there's also water there to facilitate those microbial transformations. Now, once we start to get away from those ideal temperatures and conditions, nitrification rates can slow down quite a bit. If we talk specifically about different rates of nitrification in some of our soils that are commonly cropped in the Arkansas Delta, I just have a table here that has soil series, the textural classifications, and then what we refer to as the ammonium half-life. And the best way to describe this is the number of days that it would take for the ammonium, for 1/2 of the ammonium to be converted to nitrate. So for instance, if we think about a commerce sandy loam, if I started with 100 pounds of ammonium in 9.2 days, I would be left with 50 pounds of ammonium, and I would have transformed 50 pounds of the ammonium to nitrate. So after roughly 9 days, I'd have 50 pounds of ammonium and 50 pounds of nitrate. This is a relatively slow nitrification rate because we have a long or a large half-life. If I go down here to a Sharkey clay, which is very commonly cropped to rice, you can see that I have a much smaller ammonium half-life, which means I have a much quicker nitrification rate, right? It's over twice as quick as the nitrification rate for the commerce sandy loam. So in this instance, if I started with 100 pounds of ammonium, in roughly 4 days, I would be left with 50 pounds of ammonium and 50 pounds of nitrate. So as you can see here, as we change not only our soil series, but our soil texture, we can have very significant differences in that nitrification rate. So the next thing I want to talk about is another one of our nitrogen loss mechanisms, which is denitrification. So this is very different than ammonia volatilization loss in the sense that denitrification is restricted to a subsurface loss mechanism. So in order for ammonia volatilization to occur, we have to have that urea or ammonium on the soil surface. That's where that loss mechanism will occur. However, when we talk about nitrification, when we talk about denitrification, this is restricted to the subsoil or below the soil surface, and it is a subsurface loss mechanism. Now, what's required for denitrification to occur? You have to have nitrate. You have to have actively respiring soil microbes. So typically that means you need organic matter, you need warm soil temperatures. But the key thing here is that you have to have saturated anaerobic soil conditions. So typically what we see is that the microbes in the soil, since there's no oxygen present, they start to look for other compounds to use as terminal electron acceptors. One of the most commonly used ones is nitrate. And so as those soil microbes are respiring, they're eating that soil organic matter or those readily available carbon sources, they look to nitrate to dump their electrons on as a terminal electron acceptor. And so they start to convert that to either nitrous oxide or dinitrogen or into gas, and those are going to be lost from the soil. Now, once again, nitrification requires oxygen. Denitrification only occurs when oxygen is not present. So the two conditions for those to occur are going to be very different. You can see here down in the notes, we can lose up to 60% of the nitrogen fertilizer in 4 to 5 days. So this can be a very rapid, loss mechanism, especially if environmental conditions are favorable. So back to the original question, how much nitrogen did I lose? And I think we really have to piece this together by saying, was ammonia volatilization a potential loss before, the nitrogen was incorporated? What's the potential nitrification rate based on my soil texture, my environmental conditions? What's the denitrification potential? That's going to be based a lot on environmental conditions and whether or not the soil is anaerobic or saturated. And if we think about all those together, the answer for this is going to be very field specific. But what we can do is take some of this general information and make some estimates. So what I wanted to do is just kind of run through a scenario with you. And so in this particular one, we're going to look at estimating nitrogen loss, and we're going to call this a worst case scenario. And by worst case scenario, I mean all the conditions for nitrification and denitrification are going to be near perfect or ideal. So this is a situation where we're going to lose the maximum amount of nitrogen possible. So if we start with a Crowley or a DeWitt silt loam, and we say we apply 100 units of nitrogen, 10 days before the flood. And let's just say it's going to be an ammonium nitrogen source, whether that's urea or ammonium sulfate. So for this particular soil texture, if we think back to those nitrification rates a few minutes ago, in 10 days, roughly 65 units of that urea is going to be converted to nitrate. And then if we flood the field or we have a high rainfall event that leads to prolonged saturated conditions, that's when we're going to shift over and start to get denitrification losses. And so if we've converted 65 units of that to nitrate, that means that potentially 65 units could be lost to denitrification. And once again, this is going to be a high estimate, but that means we only have about 35 units of that nitrogen left in the ammonium form. So really that's all we can count towards, a potential pre-flood nitrogen rate or towards a season total nitrogen rate. Now, if we compare this to a sharky clay, so really all we're changing here is the soil texture, but by changing that soil texture, we're, speeding up that nitrification rate. And what we find is in that same 10 days, we can roughly convert about 88 units of that ammonium to nitrate. And so what does that mean? Well, when we get saturated or flooded soil conditions and we convert to an anaerobic situation, as much as 88 units of that nitrogen could be lost to denitrification. Well, that results in only about 12 units of ammonium remaining in the soil, which is only about 12% of the nitrogen we applied. And, in my professional opinion, that's not really worth counting towards either your pre-flood nitrogen rate or your season total nitrogen rate. Now, once again, I really want to emphasize that this is the worst case scenario, but part of why I want to show you this is that if the conditions do align, perfectly, this is the potential amount of nitrogen that you could lose in those fields. Now, what I want to do is give you kind of a probable scenario. And by probable scenario, I mean, chances are this is what we're going to experience in the field. And the reason we're going to experience this in the field is very rarely are we going to get perfect environmental conditions for, a perfect quick nitrification rate or a complete denitrification loss. And so in this scenario, kind of what I'm saying is that the nitrification rate or the conditions for nitrification are going to be, non-ideal or not perfect, which means that in that 10-day time frame, we're only going to convert about 30 units of the urea or the ammonium to nitrate. And so what that means is that when we do get that saturated or that addition of the flood, that really gives us only about 30 units that could be lost to denitrification. And so really that leaves us about 70 units or about 70% that we could count towards that pre-flood nitrogen rate. When we go over to the Sharkey clay, same type of scenario. We're going to assume, non-ideal conditions for nitrification. So in that 10-day time frame, we're going to get conversion of about roughly 45 units of the urea or the ammonium to nitrate. Once we get those saturated or flooded soil conditions, there's a potential that 45 units could be lost to denitrification, which leaves us with about 55 units or about 55% towards our pre-flood or season total in rate. So what I kind of tried to do was just, show you how variable the nitrogen losses could be. Part of why I wanted to go through this is just to emphasize to you when we do these kind of flush nitrogen applications at the 2 to 3 leaf growth stage, part of the reason we can't count a lot of that nitrogen towards our season total nitrogen rate are these exact, nitrogen transformations and nitrogen loss mechanisms that I've tried to identify here in the talk today. And specifically when we're talking about, direct seeded delayed flood rice production, pretty much any nitrogen that is in the form of nitrate when we flood the soil is going to be lost to denitrification. And so what we're trying to do in a perfect world is apply nitrogen in the ammonium form, typically as urea, and we want to try to protect it or keep it in the ammonium form until we can flood the soil. Because if we flood the soil and the nitrogen is in the ammonium form, we've eliminated oxygen. And if we eliminate oxygen, then we eliminate nitrification as a transformation process. It's only when, oxygen is present, we have ammonium present that we can get nitrification. And then if we have nitrate available in the soil and we flood it and we get anaerobic conditions, that we can have denitrification or nitrogen loss from the soil. And when you put all these things together, that's really why, our direct seeded delayed flood production system can either have really, really high nitrogen use efficiency or can have really, really, really poor nitrogen use efficiency. As always, I would just like to acknowledge the support that we get from, the Soil Test Review Board, as well as the Arkansas Rice Checkoff. I wanted to, open it up to questions, but obviously with this being, a podcast or kind of a remote presentation, I put my cell phone number on here as well as my email address. So if there are any questions or concerns that you have related to general fertility, please feel to reach out to us and we'll try to do our best to address that for you. Thanks.
Thank you to the rice growers of Arkansas for your support through the Arkansas Rice Checkoff program administered by the Arkansas Rice Research and Promotion Board.